Functional notation part 2. We're going to be looking at using functional notation, and then we are going to look at evaluating functions. Functional notation. So we have a function, and we know that we need an input, and the function is a set of rules that gives us outputs. The input are all the x values, and the outputs are the y values. We say y is dependent on x, therefore we say y is a function of x, and we can say that y equals f of x. This terminology here, f with the x in the bracket, we call this functional notation. So for the equation y equals 2x plus 1, we can replace y with f of x. Functional notation is f with the brackets and x in the brackets, and this is read as f of x. So we have our function y equals 2x minus 4. We would say that the function is f of x equals 2x minus 4. We've just replaced y with f of x, the functional notation. Evaluating functions. Now we'll see why the functional notation is useful. Evaluate for x equals 2, f of x equals 2x plus 1. We often see this written more succinctly as evaluate for f of 2. This means evaluate the function when x equals 2. So in this function here, we are going to replace all instances of x with the number 2. So f of 2 equals 2 times 2 plus 1, which is 4 plus 1, so f of 2 is 5. And we can see this for the function when it's plotted. So here we've got f of x equals 2x plus 1. So when x equals 2, f of x is 5. The function is 5 when x is 2. Let's have a second example. Evaluate f of minus 2 for f of x equals x squared plus 3x minus 2. Again, we are going to evaluate this function when x is minus 2. So all instances of x we are going to replace with minus 2. So f of minus 2 is minus 2 squared plus 3 times minus 2, take away 2. So minus 2 squared is 4, plus 3 minus 2, so that turns into minus 6, take away 2. So evaluated, 4 take away 6 take away 2 is minus 4. Again, we can look at the function here when we plot this. So the function f of x equals x squared plus 3x minus 2. When we go to the point x is minus 2 here, and we see where this function lands on the y-axis, we can see that it does indeed equal minus 4. And that is how we evaluate functions. So to recap, functional notation is f of x, and we read this as f of x. For example, f of x equals 2x plus 1. That's the same thing as saying y equals 2x plus 1. We are replacing y with f of x. And when we have to evaluate a function such as the one above, we can say evaluate f of 2, and this means find the value of the function when x equals 2.